Today, we are going to discuss maintenance management, block 3, analytical methods and models, unit 9, failure statistics, data analytics, analysis and method of quantitative analysis. So let's understand what are the different objective of today's sessions with reference to failure statistics, data analysis, method of quantitative analysis, which is used in case of maintenance management. So the objective of today's session is you have to understand the basic of failure statistics in maintenance management, then understand the mathematical and statistical foundation of reliabilities engineering and maintenance management. Then students get acquainted with the Pareto chart, cause and effect diagrams, failure modes and effect analysis, which is shortly known as FMEA. And students also introduced to component reliabilities, hazard models, and system reliability model with reference to maintenance management to understand the deep analysis of various that is known as mathematical analysis with reference to reliabilities, and the next important part is the failures analysis. Moving to next ones. So next one we have the introductions as far as concerned with the modern or modernization of industries, starting from industries 1.0 to industry 4.0. Most of the cases, the production department is required highly sophisticated equipment and machines. So if you observe the point number one, modernizations and urgent need of higher productivities are brought with the sophisticated equipments and machines. So if you want to go for maximize the productions, you need highly that is known as automated machines, sophisticated machines, and you are also using the flexible manufacturing systems to enhance the productivities. So for sophisticated plant and machines, in general, Systols incorporates newly technologies and design, which is generally is not adequate province, and also in most cases consist of large number of assembles, sub-assembles, and components. Therefore, that tends to higher probability of failures. So this point directly provide the intention in case of if a company is used sophisticated machines, so that sophisticated machine consists of large varieties and large number of assembles, sub-assembles and components. So it is not only include the components, some amount of complex and precise components are there. So there may be high probabilities of failures if you go for higher productivity by the help of sophisticated plant and machines. So that is why these are basically cause a large amount of failures, disruption in productions, and the results that is loss of availability of the systems in the form of machines, tools, and also the result increase in case of direct costs of the maintenance. So whenever you think about these sophisticated machines, the chances or probability is very much higher in case of failures, and this failure which causes large amount of that is known as disruptions in the productions, and as a result the cost of maintenance also increase, whether the companies implement preventive maintenance, predictive maintenance or proactive maintenance in the particular departments. So let's understand what are the different kind of causes which directly restrict the productions, resulting the loss of availability of the systems. Moving to next important part. So the next important part we'll discuss that is known as basic failure statistics. So before elaborating this particular session, we have to understand what is failure rates. So failure rates is a frequencies with which an engineering systems or component fail, expressed for example in failure per hours. So if you go for the fundamental definition of failures, it is a frequency with which the engineering system or a component is failed, which is known as failure rates. So the failure rate is directly depend upon that is usually time dependent, and intuitive polarly it is rate changes over the versus the expected life cycle of the systems. So whenever the failure is occurred in a time dependent manner, that change the expected life of the systems, That means the system consists of a large number of that known as machines, equipments, and tools. So, in case of failure rate, it is also known as the time between failures is closely related to the failure rate, which is denoted as lambdas. So, let's take an example of a automobiles which grow older, and the failure rate, its fifth year of service may be many times greater than its failure rate during the first years. So one simply does not expect to replace an exhaust pipe or overhaul of the brakes or the major transmission problem in the new vehicles. So in this particular failure rate, let's understand with the example of a car which is purchased initially, and the rate of failure in case of for the first year is less than as compared to the failure cases occur in the fifth year. So that directly provide the replacement of various component. For example, component like exhaust pipe, then overall of the brakes or brake pads should be changed or replaced, and if required, some cases the transmission problem will be occur, and that to be replaced as early as possible to avoid the failure in case of the vehicles. So if it goes to point number four, the failure rates and their projective manifestations are important factor in insurance, in business, regulation practices, as well as the fundamentals to design of the safety of the system throughout the national international economies. So this is not only the case of automobiles, these are also implemented in the manifestation of different areas like insurance companies, like automobile business, like regulation practices by different agencies, and it also brought a huge amount of fundamental to the design which provide higher side of safety to the system throughout the national and international economies. So that is why the failure statistics should be properly analyzed for a particular equipments, for a machines, so that to avoid the failure rate and increase the productivities of a particular organizations. So let's understand by the help of your Bartu curve. In the previous session, we have discussed the detailed overview of Bartu curve, which is basically conducted between failure rate versus times. So this bar tube curve has three components, that is known as infantry or early failure modes, then constant or random failures, and then wear out failures. So in case of the first parameter, that is early infant mortality failures, that decrease failure rate because the product is new and the failure rate is decreased. Similarly, whenever you use this particular equipments or machines over a period of more than 5 years, 6 years, maybe 10 years, in that cases the constant failure rate should be observed. And here the random failure should be observed in case of the maintenance department will replace most that is known as a critical component for the machines so that they can provide a higher or availability of the system should be in a such a manner that will provide higher set of productivity. But in the last stage that is known as wear out failures, in that cases increase failure rate frequently and which increase the failure rate with reference to the times. So depending upon the Bartu curve, as I told, this basically focus upon three parameters: the infant mortality failures, constant random failure, and wear-out failure. It depends upon the mean time between failure, which is closely associated with the failure rate, which is denoted as the lambda. And whenever you go for that is known as Bartu curve with reference to number of machines, number of equipment, it basically analyzes the expected life of the systems. Moving to next one. The next one is basic rate in case of discrete sense. So let's understand what is the different aspect of this discrete sense in case of failure rate. So the word appearing in case of experiment, failure rate can be defined as the total number of failure within an item populations divided by the total time expanded by the populations during a particular measurement interval under stated conditions. So as I told, the most of the cases, the total number of failures, or you can simply pronounce as the mean time between failure, that of a particular populations that divide by the total time expended by that population during a particular measurement intervals. So here failure rate lambda function of t can be thought of as the probabilities that a failure occur in a specified interval given no failure before the time t. So if you go for the mathematical expressions, it can be defined as the aid of reliabilities functions or survival function, which is denoted as R function of time t. The probability of no failure become time t, which is expressed as lambda equals to R, the first time period t1 minus R function of t2 divided by t2 minus t1 into R t1. So if you go for further expression in case of that is known as mathematical point of view, so this lambda equals to RT minus R into T minus del T divided by del T into RT. So here T1 and T2 are the beginning and ending of a specified interval of the time spanning, that is del T. And here you have to note that this is a conditional probabilities, hence the R and T is the denominators. So let's take the example of the same bar tube curve. So here three parameters are there, that is known as early failures, random failure and wear out failures. So it is basically done for the identify the probability of no failures with reference to the early failures, random failures and wear out failures. And here the lambda t basically represent the failure rate and t stand for the time periods or time interval, which is denoted as t1 and t2. So t1 stand for that is known as your initial times interval and t2 stand for the ending time interval, specified interval of the spanning, that is delta t. So this is the mathematical expression for failure rate in case of discrete cells. Moving to next ones. The next we have to understand the failure rate in case of continuous cells. So let's understand what are the different parameters and what are the different mathematical expressions with reference to this failure rate in continuous cells. So by calculating the failure rate for smaller and smaller interval of times, the interval becomes infinitely small and this result in hazard functions, which is the instantaneously failure rate at a point in the time. So that can be denoted or mathematically expressed as h function of t limit del t to 0 and that equals to your RT minus RT plus del t divided by del t into RT. So this is equation 1. Similarly, if you go for continuous failure rate depends upon the failure distributions. So which is a cumulative distribution functions that describe the probability of failure prior to time t. So t less than equal to, capital T less than equal to t, that equals to function of t and the function of t is expressed as 1 minus RT. Here t is greater than equals to 0. This is equation number 2 for failure rate in case of continuous cells. Then if you go for that is known as t stand for the failure times and failure distribution function is the integral of the failure density function, which is denoted as function of x. So here the function of time with respect to 0 to 2 function of x into dx. So this is equation 3 for the failure rate in case of continuous cells. Moving to next ones, to understand the hazard function, which can be expressed as st equals to function of t divided by rt. This is equation 4. The next is many probability distribution can be used to model these failure distributions. The common model exponential failure distribution is function of t integration of 0 to t lambda t to the power minus lambda x into dx and that equals to, or you can simply pronounce as function of t equals to 1 minus e to the power minus lambda t. So this is the common model for the exponential failure distributions, which is known as equation 5 for the continuous sense in case of failure rates. So based upon the exponential density functions, which is denoted as ht's, that is function of t divided by rt, so that equals to lambda e to the power minus lambda x divided by e to the power minus lambda x. So that equals to lambda. So here exponential density function equals to your failure rate, which is denoted as lambda. This is equation number 6. So by using various parameter with reference to failure rate, with reference to that is failure density function like f of x, or you can go for that is known as that is known as failure times. You can easily calculate the failure rate for continuous cells in case of failure distributions, which is directly or indirectly depend upon various hazard function of a particular system. So moving to next one. So for failure analysis, we require large amount of failure rate data. So let's understand what are the different sources which basically provide large amount of failure rate data. So the first one is historical data about the devices or the system under considerations. So for example, maintenance management department will conduct a surveys and collected various amount of historical data of that particular device. So that data includes who is the manufacturers, who is the suppliers, what is the specification of that machines, what is the functionality of the machines, what are the different SOPs are there, what is the different parameters are basically considered in case of these data. So if you read out the point number one, many organizations maintain internal database of failure informations on the devices or the system that they produce, which can be used to calculate the failure rate for those devices or systems. So as I told, that large amount of database should be used in case of failure informations on the particular device or the systems. Even if necessary, they can ask the operator who basically run the devices or run the systems. Moving to next ones, the next agency is that is known as government and commercial failure rate data. So there is large amount of availability of handbooks or failure rate data for the various components are available from government and commercial sources. So several failure rate data sources are available commercially. For example, commercial components, including some non-electronics components are there. The next one is that is known as testing. So the most accurate source of data is to test the samples of the actual devices or the system in order to generate the failure data. So here the accurate data should be used to analyze the failure rate and which provide the accuracy in case of calculation or in case of estimation of failure rates. So that is why whenever you go for testings, accurate source of data is go for testing the samples of the actual devices or the system in order to generate the failure data. So this is most expensive so that previous data sources are often used instead. So due to accuracy of source of data are very expensive. That is why most of the cases the organizations should defer historical data about the devices or system and they collect the reference of various handbooks provided by the government and commercial agencies. Moving to next ones. So let's understand the failure rate calculation, how the calculation should be done. So let's take an example of a that is known as estimation of failure rate of certain components. So a test can be performed to estimate the failure rate. 10 identical components are each tested until they are the fail or reach 1000 hours, at which the time test is terminated for the components. So here total 10 number of components are given and there that is known as failure times or the most of the maximum identical components and their fail or reach the 1000 hours should be estimated and here failure rate should be calculated. So if you go for the result, component 1 is run 1000 hours, no failures. Component 2 is run 1000 hours, no failures. Component 3 is 467 hours, failed. Component 4 is 1000 hours, no fails. Similarly, if you go for fifth one, 630 hours run and failed. Similarly, sixth one, that is 590 hours, failed. Component 7, 1000 hour run, no failures. Component 8, 285 failed. Component 9, 648 hours run, but the result is failed. And last one is component 10, that is 882 hours run and provide the result of fails. So if you observe the number of calculations, total hours of 10 component run 7,502 hours. And if you calculate the number of failures or number of that is known as fails, that is known as 6 out of 10. So the component 9, component 8, component 6, component 5 and the next one is component C. So total 6 failures are there. So 6 failures divided by 7,500 total hour of runs, that equals to 0.00798 failures per hour. So if you convert this one, 799.8 into 10 to the 6 failures per hour. So the estimated rate of failure is 99.8 failures for every millions hour of operations. So this is the way to calculate the failure rate for a specific department who have number of identical components. So in this way, most of the cases, the large scale industries, the medium scale industries, and the small scale industry are basically calculate the failure rate for different components. Moving to next one. So let's take another examples, failure rate calculations. So first one is a disk drive mean time between failure number may be, that is 1 lakh 200 hours, and the disk drive may be running 24 hours a day, 7 days a week, and 1 year has 8,760 hours. So how to calculate the failure rate? So total number of hours which is already given, that is 12 lakhs hours divided by total number of hours per year, that is already given in the questions, 8,760 hours per year, that equals to 136.9863 years. And if you go for reciprocal of 136.9863 years, that is one failure divided by 136.9863 year into 100. So that equals to 0.73%. So you can expect about 0.73% of population of this disk drive to fail in the average years. So in this way, you can also calculate the different components failure rate with reference to different departments, different companies, different organizations. Moving to next ones, the method of data analytics. So let's understand how the data are basically analyzed. So the analysis involves the step like categorizations. The next is go for codings. Then the data are represented in the form of tabulations. So here the principle for classification and categorizations of data has to be based on the problem under the studies or the hypothesis formulated. So let's understand that is known as from the block diagram how the data are analyzed. So if you go for data analysis, it is basically divided into two components. The first one is processing of data, that means preparation or preparing the data for analysis. And another point or another component that is known as analysis of data. So under the processing of data, we have go for the first step that is known as editing. The second step go for that is known as codings. Then the third step that is known as classifications. Then the fourth step that is known as tabulations. The next step we have that is known as using percentage. So these 5 number of parameters should be done under the processing of data, or which is known as the preparation of data for analysis. But on the other side, in case of analysis of data, you have to go for first two components that is known as descriptions and causal analysis. And the second part will go for that is known as inferential analysis or statistical analysis. So under statistical analysis, we'll go for estimation of various parameter values, and in the other hand, we'll go for testing the hypothesis. So in this way, the data should be analyzed in case of identify the failure rate with reference to inferential analysis or with reference to statistical analysis. So before going to understand the different methods of data analysis, we have to understand how the data analysis process are undergoes. So the first problem is that whenever you go for data analysis for failure rate, you have to first define the problems. So after defining the problems, then collect the various form of data, whether in the form of primary state of data or secondary state of data. Then go for data filtration or data cleaning should be done. Then analyzing the data by the help of various softwares. Nowadays, most of the cases, in case of statistical analysis, large variety of software is available. Then by the help of that is known as tables, you can go or any chart and control chart, you can directly go for data visualizations. And finally, go for that is presenting the data to the higher authorities regarding the data analysis process for a specific machine and a specific equipment. So these are the 6 number of steps. I repeat: define the problems, collect the data cleanings, analyze the data visualizations, and the last one is presenting the data. Moving to next ones. So before go for data analysis, you have to go for the classification of data. So in case of classifications, it is of two types. One is qualitative data, another is quantitative data. So in case of qualitative data, we have ordinals, which is known as ordered data. The second one we have that is known as nominals, that is non-ordered data. For example, ordinal data is basically go for test the grades, and in case of nominal data, which is not ordered data, the example is nationalities. On the other hand, in case of quantitative data, we have continuous data that can be divided, and we have discrete data that cannot be divided. For examples, distance, and in case of discrete, that is known as cats. So, for undertaking and meaningful research in case of data analysis of situational assessment, testing the various models, development of theories, evaluation of economic policies, the data are very essentials. So if you go for that is known as theoretical aspect of classification of data, so we have time series data, we have cross-section data, we have pool data, we have panel, longitudinal or micro panel data are there, and the last one we have the source of data. So let's understand in case of time series data. So it is a set of observations on the values that variables takes at different times. Such data may be collected at a regular interval, such as daily, or we can take the example of price, like gold price, commodity price, weather reports. These are basically under the time series data. So daily wise or weekly wise, like monies, supplies figures, or in case of monthly wise, the consumer price index. In case of quarterlies, the GDPs. In case of annually, government budgets. These are the basic example of time series data. So moving to next one, the next one we have cross-section data. So these data are one or more variable collected at the same point of times. So let's take the example of census of populations collected by the Registrar General of India. So this is the typical example of cross-sectional data for implementing various amount of policies in the state, in the countries. The third type classification data that is known as pool data. So pool data, the element of both time series cross-sectional are cubed. For examples, over a period of time, says starting from the year 2000 to 2030 for a companies. So that is known as the pools should be ranged from the year 2000 to 2030 for a specific companies to estimate the different element and cross sections are basically cubed. The next we have that is known as panel or longitudinal or that is known as micro panel data. So this is a special type of pool data in which same cross sectionals like families, farm is survey over the times. So next one we have that is known as source of data. So data usually empirical analysis and may be collected by the government agencies like CSOs, NSSO, RBIs, labor bureaus, and international agencies like International Monetary Fund or a private organizations. So these are the typical source of data. So by the help of the classification data, as I told, that is known as time series data, the next cross section data, pool data, panel longitudinal or micro panel data, and source of data. We can easily go for meaningful resources or research in terms of situational assessment, testing the different models, then development of theories, evaluation of economic policies. These data are vastly used to reform any kind of the economies as well as any kind of organizations. Moving to next one. The next one is research design versus research methods. So let's understand what is research design and what is research methods. So research methods are basically made of data collections and the techniques of data analysis, whereas the research design is the logical structure of a queries. So for example, equating the cross-sectional design with query questionnaires or case study with the participants and observations result evaluations of research design against the strength and weaknesses of the method rather than their ability to draw the relative unambiguous conclusions or to select the rival plausible hypothesis. So research methods are made of data collections and research design are the basically logical structure of inquiries. So in case of logical that is known as inquiries, the that is known as research designers is basically provide the set of questionnaire. Through the set of questionnaire, they can easily collect large amount of response in case of the strength and weaknesses, and that are basically provide the plausible hypothesis for the research methods. So let's understand what is the different differentiation between research design and research methods. So research methods are procedure that will be used to collect and analyze the data, and research design is overall structure of the research. As I told, these are the logical structure for an inquiry. Similarly, if you goes to point number two, the research methods focus on what type of methods are more suitable to collect and analyze the evidence needed. In case of research designs, it focuses on what type of study is planned and what kind of results are expected from the research. And if you go to last point, in case of research methods, it's depend upon the research design. And here, the research design is directly based upon the research questions or the problems. So these are the common difference between research design and research method. I repeat, research methods are made by the collection of data, and research design is based upon the logical structure of inquiries by providing large set of questionnaires. So if you go for that is known as research method, first you have to go for identify the problems, then collect and gather the data, define the hypothesis, test the hypothesis or you have to conduct the experiment. If yes, it goes to the new data agrees. If no, again you have to formulate the hypothesis. So in this way, most of the cases, the research design and research methods are conducted to identify the different statistical failure rate of different component inside the organizations. So moving to next one, analysis of qualitative data. So in case of analysis of qualitative data, first if you go for the steps of this particular data, then we have to understand what are the different parameters should be considered by the researchers who basically focus upon research design and research methods. So first one is finding and collected with the help of qualitative tools which involve continuous process of data generation and analysis. It is a iterative rather than being linear, and it involves the constant comparing and constanting of the nodes, meaning thereby the researcher must focus upon who is saying what in what context. So to understand who is saying what and in what context, you have to go for doing the analysis of various that is known as steps, which is basically followed under qualitative data analysis. The first one is that is known as completion of field notes, and observations are recorded in the field diaries. So basically, in organization point of view, those who have conducted that is known as various surveys, they can send their executives to the fields and they can observe and notes and record it in the field diaries. Some scholars prefer to have complete the verbatim accounts of data. Then step number three, transcript, but other option to use that is known as index recordings and notes should be done. Then interrogation of data and diligence shown by the researcher is the key to producing good transcription and the reliable generalizations. Then data should be converted into codings, and it is basically based upon the themes which is developed to capture the meaning of your research. The grounded theories that causes the concept development in the field by respondent is an important way to theorize and analyze the quantitative research. And by the help of both computer and manual analysis, that is known as solving mathematical analysis, can be done. And finally, you have to provide the atlas or TI in some computer software used to go for analyze the quantitative analysis. So Atlas and TI are the software which is basically used to go for qualitative system analysis. Moving to next ones. So if you go for summarization of data step by step with reference to qualitative data analysis, first step is that organization of the collected data. They transcribe the interviews, translate the data, record the details, then label the different contents. This is step number one. In step number two, identification of the framework for your research. And this framework is the coding plan to the structures, label, and define the data sets. Then the next one is categorization, that is known as sorting the data into a frameworks, the descriptive analysis based on the framework, and if required, if you go for the last step, that is known as second order analysis. That means you have to go for identifications, then next is consolidations, recurrence, themes, pattern present in the data. So these are the different steps should be obtained or it is known as followed in case of analysis of qualitative data. Moving to next ones. The next one is data analysis techniques used in qualitative research. The first one we have that is known as codifications. So I have given the different codings. For example, the let's understand what is code and why coding is used in case of research, especially reference to data analysis techniques used in qualitative research. So coding is a formal representation of analytical thinkings, and codes are the tags or labels for assigning the units of meaning in case of descriptive and inferential information or statistical informations compiled during the studies. So code are generally or usually assigned in the form of alphabets, word, phrase, or sentence. So few examples of coding I have given here, that is known as program, which is shortly known as, or code is given PROG, that meaning is program. Then ORGs, which stand for organizations. Then OB stand for observations. OBS are the observations. P stand for participants, and PS stand for participant, S stand for staff, then PROG cytology, that is program ideologies, PROG process, that's program process, group proc, that is PROC, that is group process, then sub hyphen G, that is known as subgroup formations. So these are the common coding which is given to the qualitative research. So let's understand from other point of views. So whenever you start for codifications, the start with the data, then convert into the group into themes and provide different amount of colors to the themes. That means, for example, you have classified a data with reference to a class which consists of large amount of male and female students. So depending upon the male and female students, you have to provide different amount of color coding. So let's take an example of a organization which consists of 4 and 5 variety of machines. So each variety of machine should be converted into a group, and these groups are basically provide the theme of with respect to their functions. So depending upon their function, you have to provide different that is known as color themes, so that whenever a new person is introduced to your system, by the help of these color codes and themes, they can easily understand what is the functionality of that kind of machines. So that is why codification is necessary in case of data analysis techniques, especially for qualitative research. Moving to next ones. So after codifications, we have to understand what are the different classification of codes. It is basically in case of literature of qualitative research for qualitative data analysis, especially for codings, and variety of types of codes exist, but for beginners, it is of two types. The first one is descriptive codes and pattern codes. So let's understand what is descriptive codes. The data entails little interpretations. For example, a study on a school innovations. The code should be MOT for motivations. The teacher's motivation stand for TR mode MOTs, and ADM mode means administrator motivations. So for motivation, they are shortly provide the coding that is MOTs. For teacher motivation, they provide the coding that is known as TR MOTs. For administrator motivation, they provide the code ADM MOTs. Similarly, if you go for pattern codings, the pattern codes are inferentials or exploratories that identify the emergent themes of explanations. For example, that LM stand for that is Lee motif, then PATT stand for pattern, TA stand for theme, COMT stand for commitments, and ATT stand for attitudes. So these are the different types of that is known as classification of your course, which is we have already discussed. That is known as descriptive course and pattern course. Moving to next ones. The next one is categorization and classification of data. So let's understand what is class categorizations. So it is the process of identifying the pattern in the data, recurring the ideas, theme, perspectives, descriptions that depreciate the social world you are studying. And this is intellectually challenging phase or the data analysis. So let's take an example of this particular figure which is given on the right side. That means human or softwares. So if you go for that is known as categorized, that is unstructured data are there, because human and software is not interrelated. Similarly, if you go for that is known as categorized point of view, that means in case of humans, we require passports, health record, financial records, job postings, strategy plan, file types. In that cases, the classified rules apply. That means high risk, medium risk, and low risk are there. So moving to next one, in case of classifications, let's understand what is the different meaning of classification with reference to data analytics. The classification is a way of knowing that we have to be cognizant of the attributes of the things to be able to group them. And in fact, in the early days, the science was considered largely the way of developing classification systems. So in case of classifications for scholarly fields or research field, classification still a major objectives. For example, in case of botanical classification with reference to plant science, the periodical table in case of chemistry as well as known as the classification of schemes. So these are the typical examples: botanical classification or plant science classifications, as well as chemical classification with reference to the periodical tables are the best example of classifications. Moving to next one, the next one is method of qualitative analysis. So the commonly used method of qualitative analysis can be classified under two main heads. The first one is method of sorting and ranking of problems, or affect and analyze to identify the main cause of these problems. And second one is that method of analysis of different mechanism of failure or failure modes. So let's understand some vital fuse versus tribal manies and the Pareto charts. So here what will happen? In case of understanding the previous one, that means methods of qualitative analysis. In that cases, we have to focus upon the first one is method of sorting the data, ranking the data as far as concerned with the ascending and descending orders, or analyze to identify the main causes of problems. This is one head with reference to qualitative analysis. And the second one is method of analysis of different mechanism of failures. So here we are basically using the root cause analysis, fishbone analysis, cause effect analysis. So let's understanding by the help of some examples. So here is the example that is known as Pareto charts. So in case of Pareto chart analysis, it is a simple techniques to analyze the problem and recurrent the failure of component and the product. So here 80-20 principle is applied. That means the essence says that, or this particular philosophy says that 80% of problems or non-conformalities or failure are caused by 20% of causes, and the analysis used to sort the vital few causes from the tribal manies. So if you consider the examples, in that cases, the manufacturer of a personal computer has recently encountered an increase in non-conformities or problems or failure in finished goods. So let's take the example of the desktop manufacturers like Dell, like Intel's, or like other that is Jabronics companies. So they identify that the increase in case of failures in finished goods. So they want to conduct the Pareto chart analysis to identify the failure rates. So data were collected, organized under the different heads as given in the pie chart in the figures, and non-conformalities in personal computer. So what are the non-conformalities? Let's understand from the pie charts. So if you go for the first one, missing screw tapes, that is 45%. The next one is damaged drive controls, that is 25%. Then missing screw, that is 12%. Scratches frame, that is 5%. Damaged speaker, that is known as 4%. Damaged hard drive, that is known as 4%. Damaged disk drive, that is known as 3%. And damaged cover, that is 2%. So different aspect of or different heads are given with reference to Pareto charts. So here major causes of failure rate is observed in case of missing screw tapes. And second one is damaged drive controls. These are the two measures. And third measure is missing the screw in case of assembles. So these three should be analyzed and provide the result with reference to 45%, 25%, and 12%. So the authorities should be provide large amount of solutions to avoid these non-conformalities so that they can easily avoid the failure rate in case of that is one of the personal components. So in this way, it is also applicable to industries where they can easily identify by apply the 80-20 rules by the help of Pareto laws or Pareto philosophies to eliminate the percentage of failures so that the availability of system will be ready for the productions. So let's understand the next philosophy, that is known as cause and effect analysis, which is also known as fishbone analysis. So here what will happen, the reassemble of skeleton of a fish, it is look like the reassemble of fish, that is why it is known as fishbone analysis. And the diagram consists of the central spines with the fish head, that means the box containing non-conformalities or the effect, the undesirable events under the considerations on the right side. So there are number of diagonal ribs are coming out on the central spines. At the end of that is rib, a small horizontal box is there. Describe the major category of causes and major contributors in case of non-conformity such as machines, methods, material, operator, and the working conditions. So if you observe this figure in case of fishbone analysis, so the head define the problems and different that is known as major categories are basically connected to the contributor like manpowers, method, machines, materials, then mother natures, and then the last one is measurements. So you have to go for the fundamental aspect of this fishbone analysis. You have to identify the major contributors and identify their non-conformity like errors. So error in case of machines, methods, material, operator, and environmental conditions. So how to solve this particular problems? Let's take example of that is known as machines, and the machines has basically provide, or let's take example of automobiles which have dents. So dent is a problem. In that cases, you have to assign the operators, material handling department, provide the raw material, product design, and systems. So in case of operators, we have to provide trainings, lack of incentives, attitude, and physical, that is known as things should be considered. Similarly, in case of material handling, that is careless handling, this is the cause. And the next is material, that is availabilities, very thickness, inherent is there. Similarly, in case of product design, you have to go for pin diameters, hinge width. These are the technical things which is included to repair the dents. Similarly, in case of system, you use various methods and use the control system to control the system. For controlling, you have to implement inspection of component, and in case of method, you are using bending sections. So by bending the section, you can repair the dent. So these are the different that is known as contributors, and their respective non-conformities should be mentioned. So whenever the authorities want to go for that is known as cause and effect analysis, they first identify the causes. For examples, in case of operators, lack of incentives, this is the causes, and that is next causes, that is known as attitudes. So by providing various amount of bonuses, trainings, you can increase the dedications of operator towards the machine. Similarly, in case of material handlings, you have to find the causes that is known as careless handlings. So in that cases, you have to motivate that particular department so that they will not carelessly done the supply of raw materials from one workstation to other workstation. Similarly, in case of materials, the causes is varying the thickness inherent. But the thing that you have to provide the metal on just-in-time concept so that the availability should be ready for the repairing the tanks. Similarly, in case of product designs, it required pin diameters. So due to the pin diameters, in that cases, you have to go for hinge width or increase the hinge width to provide the design aspect of this particular tanks. Similarly, in case of systems, you have handed the methods, the control, and the inspection of components. So these are the causes and effect of analysis with reference to different that is known as systems to analyze various form of data so that the failure rate will be increased and problems will be solved within the stipulated times. Moving to next ones. The next topic we have failure modes and effect analysis. The complex system failed through the various means or in various way resulting from the different physical phenomena or different physical characteristics of individual components. So in case of that is known as failure mode effect analysis, you have to focus upon the first that is known as potential, then M stand for mode, that is the way of possibilities, E stand for effect, that is known as negative effect on the process under studies, and analyze or analysis is study of risks to reduce it. So this is the fundamental aspect of your failure mode effect analysis and how it should be applicable to different area. For example, it is applicable to new design, it is applicable to new technologies, it is applicable to new process, it is applicable to new environment, new locations, product design changes, new applications, process design changes. So if you go for the categories of failures that refer the failure modes, and failures modes are observed manners in which the components fail. So if you go for the example, the failure modes include short and open the circuits, ruptures, power losses, fractures, bringing out the tolerance, loss of outputs. These are the different example of your failure mode analysis. So how to overcome this failure mode analysis? You have to focus upon the potential of failures so that you have to easily identify the root cause analysis of failures. And the next one is you have to use the mode, that means type and way of possibility to avoid the failures. And that is known as E stand for the elimination of or different negative effect during the study of failures. And in case of analysis, you have to go for the study of risks and reduce the risks in case of failures. Moving to next one, how this failure analysis will be go for that is known as used by various industries. That means the failure mode and effect analysis is a formalized design process with the objective of improving the inherent and intrinsic reliabilities of the systems or components. So this is an iterative process, number of steps are there, and it influences the design of the systems or design of the equipment by identifying the failure modes and assessing the probability of occurrence and their effect on the system. The next one is isolating their causes and determine the corrective action or preventive measures. So therefore, the failure mode effect analysis program should be initiated early in the system or it is applicable to the equipment design phases so that the reliability design process with reference to failure mode effect analysis and the failure mode effect and critical analysis, which is shortly known as FMECA, provide the design tools that measure the progress towards the system reliability goals and indicate the area of redesigns. So during the initiation of product designs, if you rectify the number of design process of the parts, components, spare parts, you can easily avoid the various amount of that is known as design tools which leads towards the major progress of system reliability goal, which is denoted in the form of higher side of productivities, higher qualities, and the next is smooth flow of that is known as running of machines and equipment, and the next is availability of system for the production activities. So let's understand what is the different influences of design of the system. First, you have to identify the failure modes. That means you have to go for analyze the system, product, process, determine potential failure modes. That means way it could fail. The next step we have that is known as determine the failure effect and the causes. So under these steps, we have to focus upon identify the impact of each failures on performance, safety, or the compliance. The next one is determine the root causes of failures. The third one or third step we have that is known as assess the risks. That means SOD rating or RPN calculation should be done. So S stand for severity, O for occurrence, and D for detections. So if you go for the severities that impact upon the failure, that should be given the rating that is known as 1 to 10. And the next thing is occurrence, that means livelihood of failure happenings, that also rating from 1 to 10. Then detections, abilities to detect the failure before it happens, they're also given the rating 1 to 10. So how to go for risk calculations? The risk priority is number or RPN equals to S into O into D. That means you have to go for multiplication of severities, occurrence, and detections. The next is step number 4, that is known as develop and implement the action plan. Under this process, you have to go for address the high risks of failures by designing the solutions, implement corrective actions to reduce the severities, occurrence, and improve detections. The last step of your failure mode analysis that monitor and improve. That means under this step, you have to go for continuous tracking the effectiveness of implement actions and update the failure mode effect analysis as the process evolve or new risks is emerged. So these are the 5 number of steps which is used under failure mode effect analysis. I repeat, identify the failure modes, determine the failure effect and causes, access the SOD ratings and RPN calculations. The step number 4 that is known as develop and implement the action plan. Step number 5, monitor and improve it. Moving to next one. The next one is how this failure mode and effect analysis should be done depending upon the different failure mechanisms. For example, in case of corrosions, the failure mode is failure in tank wall scheme and failure effect is tank is ruptures. The second mechanism we have that is known as manufacturing defect in castings. So casting is a process for making various amount of known as art and craft and different components. So in that cases, the failure mode is leaking batteries and failure effect is fail of torch light to light. The next failure mechanism we have prolonged excessive vibration and fatigues. So the failure mode is break in motor mounts and the failure effect is loss of engine power and extensive noise. The next failure mechanism we have that is known as contaminations by the help of dust and dirt. And here the failure mode is loss of contact and the failure effect is circuit board failures. The next is friction and excessive wear. It is basically done in case of mechanical engineering or mechanical drive. So failure mode is that is known as dry belt brake and failure effect is shutdown of production line or leak. The next is prolonged low temperatures. That means failure mode is brittle seals and failure effect is leakage in the hydraulic systems. So here I have given some example of electrical and mechanical failure with reference to different failure modes, and these are basically done by the failure mechanism of different departments with reference to mechanical department or electrical maintenance departments. So thank you. Let's overview of this particular sections. In this sessions, we have that is known as discuss the fundamental aspect of failure rate, then how this failure rate is affect the increase in productions, and how this failure rate is closely contact with the mean time or related to the mean time between failure. By the help of Bartube curve, we have understands the failure rate versus time with respect to 3 number of parameters, that is infant or mortality failures, constant random failure, and wear out failures. Moving to next ones, we have also go for mathematical description of discrete sense of failure rates and how to calculate by the help of these formulas we have discussed. Then we have also go for that is failure rate in case of continuous sense. We have that is known as exponential density functions. So the exponential density function is equals to lambda, and lambda is none other than that is known as failure rate. Then we have to understand the different failure rate data by the help of historical data about the devices or the system under considerations. Then who are the that is known as agencies like your government and commercial agency who basically provide the failure rate data by the help of handbooks. And we are also testing the different failure data where the data accuracy is most important parameters to calculate the result of failures. The next is by the help of examples, we have calculated the different identical components with reference to their working hours and calculate the rate of that is failure rate for different component of a particular department. Then we have to go for the method of data analysis. So data analysis process basically gone through the processing of data, analysis of data. Under processing, we have understand the editing of data, coding of data, classification of data, tabulation of data, and using the different percentage. So on the other hand, we have also gone for analysis of data. That means descriptive analysis or causal analysis. And the second part, we have to go for statistical analysis. So under statistical analysis, we will go for estimation of different parameters, testing the hypothesis, and we have understand the different steps of data analysis process, which includes the define the problems, collect the data cleanings, analyze the data visualizations, presenting the data. Moving to next ones. In the next part, we have go for the classification of data, which reference to time series data, cross section data, pool data, micropanel data, and the source of data, which is basically essential for meaningful research in terms of situational assessment, testing of models, development of theory, evolution of economic policies for a specific companies. So if you go for the broad classification data, so we have ordinals and non-nominal data there. And in case of what is known as quantity, we have continuous and discrete data there. So in the next part of this today's sessions, we have understand the concept of what is known as research design, research methods. So research design means data collections, and research design means logical structure for inquiries. So in the other part, we have to go for the differentiation between research design and research method, and we have to understand the research method, how this research method process are basically implemented for conducting large amount of research with reference to failure rate analysis. So first you have to identify the problems. The next we have gathered the data. The third one is that is known as hypothesis. Then test the hypothesis or experiments. Then does the new data is agrees? Yes. Then it goes to the test the hypothesis. If no, again you go for formulation of hypothesis. Then proceed the next step, that is known as test of hypothesis, and if agrees, then conclude the research. Moving to next ones. In the next part of this presentations, we have already understand the concept of qualitative data. That means it is basically a tools which involve continuous process of data generations and analysis. It is an iterative process rather than linear. And what are the different steps of your qualitative data analysis, starting from organization of the data collections, which includes transcribe the interviews, translate the data, record the details, label the content. In the second step, we have to identify the frameworks, and the framework including coding plan to structures, label, and define the data. Third step, we have that is known as sorting the data into framework. The fourth step, we have descriptive analysis based on the framework. And the last one is that is known as second order analysis. That means we have to identify consolidated recurrence, the themes, and go for pattern present in the data. In the next part, we have to understand the codification of data with reference to data analysis techniques used in case of qualitative research. That means we are using different kind of tags and labels assigning to the unit of meaning of description with reference to statistical information compared during the studies. So here in case of codification, we are using alphabets, words, and phrase and sentence. Thank you.